Welcome to another Blind 75 video, and in this particular video we'll be solving the find minimum in a rotated sorted array problem. This problem is the first among two problems regarding the which focus on the binary search concept that will be tested in coding interviews. So, but in this problem we're not going to be exactly using the binary search algorithm, but what we'll be using here is a modified version of that algorithm. Before we get to that, let's explain that concept out a little bit. Let me open the whiteboard so we can, you know, uh, exemplify exactly what we mean. So let's start with breaking out the problem in this question here. We're given an array of length n, which is originally sorted in ascending order. That's how the array should be original, right? Then it has been rotated between 1 and n times, and basically that's what it. Let's explain this concept first. So basically we have an array of a random length. Let's presume 5, 3, 2, 1, anything like that, right? So I need a darker and bigger marker. So let's say that we have an array of 3 items: 0, 1, and 2, right? That's what I say. We have an array of n length, right, given to us. Then that array has been rotated between 1 and n times. What does it mean by rotated? So rotation in this particular problem means that we take the last element in the array, which should be 2 in this case, right? Let me use another color, make it a little more clearer. Supposedly we have the last array in every in every list or array that we have. We take it back and bring it to the start of the array. That is what rotation means. That's one rotation, right? This is one rotation. So presumably we're given the array has been rotated between 1 to n times, right? So given that, uh, how we need to basically find how many the minimum value in this array basically. And the solution that runs in O of n time is trivial, but we need to write a solution in O log n time. Now, that's another aspect to it, that we need to write this solution not in O of n times, because that seems like an easy solution in this problem. So our time complexity must not be O of n times. It must not be O of n times. Rather, it must be, let me cannot be O of n times, but it needs to be O of log n time. That is what it needs to be. It needs to be O of log n times. So given that, how would we solve this problem? If it was a simple, let's remove this, let's remove this arrow here. If it was a simple problem, right? If it was a simple array like this, which is already sorted, right? We can quite easily say that, hey, you know, that the lowest item is going to be the one that is the first value, right? That's easy. That this becomes the lowest value. But given that we don't know how this sorted array has been rotated, how do we find that value? Because we're going to give different values with, I don't know how many times it has been rotated between 1 to n times. And rotation, as we discussed, is moving the last element right to the start, right? So we need to come up with an algorithm that through which we can identify the lowest value in O log of n time as soon as possible. So that's the challenge in this particular problem. So given that, let's move to a new array that we can use. And let's say this array is given to us: 3, 4, 5, right? Then 1 and comma 2. This is the array that we have that we need to find the lowest value, right? And we don't know how many n times. Let me change the color here. We don't know how many n times this has been rotated, right? We don't know the rotations in this. I mean, we can see the rotations if we physically see it, but the program doesn't know how many rotations have occurred, right? Given that it was, uh, you know, uh, given that it was, an assorted array which was rotated, we can see that it was rotated 3 times because, you know, by human eye we can see that 1, 2, 3, 4, 5. So 5 from the start was rotated out first, then 4, then 3, from the top to the back, and that's how it became like this, right? So what is our binary search algorithm solution? How do we need to modify binary search to find the minimum value? So with everything, as we've discussed, there's the left pointer and we have the right pointer, right, in binary search. But in this case, our focus would not be on the left or the right pointers, but we'll be focusing on this value here, this middle value, right? Because we need to understand where we are in the middle value. If the middle value is greater than equal to the value right on its right, which is m plus 1, right? What does this mean, right? It means that the minimum value is going to be, let's change the color just to highlight that, this means that the minimum value is going to be, or the lowest value is going to be this value. Is going to be the lowest value, right? So that is basically what we can presume, right? Because if the value next to the middle value is lower than it, then it is the lowest value. How can we presume that? If you notice here, there's something very simple to understand about this. As these were sorted in a proper order, you'll note that we have both of these. This list is still sorted, but in a twisted kind of manner. This section of the uh, entire list, the right section, is sorted properly, and this section on the left is also sorted properly, right? So if one value is lower than the other, like in this case here, it means the value before that particular value are sorted properly, and the value ahead of it is also sorted properly, just not have a common relationship with this middle value, right? So we will also know that both of these values were of the same list. But if a bigger value, if we do the rotations, obviously after the bigger value, the list restarts, which means that that is going to be the lowest value. That was the first value in the list before the rotations occurred. So that is the presumption under which we can understand that this problem would be solved. And that is the entire concept and the idea behind this particular problem that we need to do. And this is how you'll do the binary search, which is going to be uh, how we modify the binary search basically to get your answer. So with that out of the way, let's code this problem out basically. So to start off, as we discussed, we're going to be two pointers performing the binary search. Then we need to compare the middle element with the rightmost value. And if the middle value is greater than the rightmost value, it means the minimum value must be the right half of the left pointer, which is m plus 1. And if the middle value is less than equal to the right value, then it means the minimum value is either at mid or in the left half. So we move to the right pointer to the mid, basically. And we continue this process of left and right until we reach the left or the minimum value, basically. So with that, let's write this problem out. First, we're going to declare the left and the right pointers. Let's start with that. So first, we're creating the 2 pointers and setting up their index values. So the left pointer is going to start right at the start of the array, and the right array is going to start at the end, which is length -1. And we're doing the -1 here because with everything in programming, presume that it's going to be 0 index. So we're going to handle that as a 0 indexed value. So with that, next we need to move to our while loop, where we're going to test for as long with the exit condition of as long left is less than right, which is again like the sliding window problems that we did before. Is that when left crosses right, that is the point where we have gone through every item in the list, so we can exit. So let's sort that out. Let's write our code. Next, we need to find the midpoint of the array. So we're going to write code to write the midpoint. With that out of the way, we're going to then do our control structures by checking whether left is middle is greater than right or less than right, basically. So we're going to test that out. So here what we're doing is that if the left mid value is greater than the right value, then we immediately bring the mid value as the left pointer forward, basically, right? So we can continue our process. But if the right value is not less than the mid value, then or greater than the mid value, in other case, we simply just bring the right pointer to the value, basically. So with that out of the way, let's move forward. Here we're returning the num's left value, which is going to be our solution. We to run this code, and both cases pass this. Our code passes both cases. So that is how you're going to solve the find minimum value in rotated sorted array problem, which is related to binary search in this problem in this line 75 section. Basically, again, we're starting by setting the left to the start of the array and right to the end of the array. Then we, in each iteration of the loop, we calculate the mid. Based on the comparison of the nums mid and the right, we adjust either the left or right arrow to narrow down our search slowly. And we terminate the loop until left and right converge at the same index, which means that the index of the minimum, basically. Our time complexity, as said above, is O log of n, where n is the length of the array, since we are halving search space in each iteration. So with that, we're going to wrap this video up, and we'll see you in our next Line 75 video. Thank you.